For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Genetic entropy is something that he mentions a lot in this book. Genetic entropy is really, really stupid.
But I'm also not a geneticist and that's not really my world. Yeah, I'll be the first one to admit that I'm not a geneticist.
Again, I'm not a geneticist. I can't say for certain genetics is not my forefront.
Because I'm not a geneticist.
Again, not a geneticist, and I'm not a geneticist. I'm not a biochemist.
I'm not a geneticist.
We should have a conversation about genetic entropy. I've heard you speak to like CRISPR and stuff like that before, and I would be very interested to have that chat. I'm not very well-versed, as I've said, for like the 20th time. I'm not very well-versed in genetics.
Yes, so here's the thing, and I'm going to use this to segue into genetic entropy because I feel like that's kind of where you're, pulling a little bit, which is fine because I got my notes right here because I don't know enough about genetics.
Again, I cannot emphasize enough how this is not my field. I would, as I've continued to kind of begrudgingly admit throughout the course of this conversation, that genetics really isn't kind of my field. I can talk to you a lot about, other stuff, but genetics isn't it. I don't know about because this isn't my field. Genetics really isn't kind of my field.
We're not going to be touching very much on genetic entropy. I feel very comfortable hand-waving it.
I'm not a geneticist.
That's not my field. I wish I could give you a better answer. I can't give you great answers because I don't know them.
Oh, idiot.
When we see genetic entropy, I'm going to say genetic entropy, and I'm going to do the genetic entropy sign, and we're going to say it's like this, and then I'm going to say skip. So I'm going to be like genetic entropy, skip.
I mean, the evolutionists will often look to gene duplication as a way to add novel information to the genome. But I mean, if I give you a copy of a book that you already own, and then I start introducing typographical errors into the second copy of the book you already own, now you just have a more messed up copy of the original book. So it's just more evidence for genetic degeneration. It comes down to net gain versus net loss. So that ain't gonna help.
Gotcha.
Quick add on that though. What about natural selection? Ooh. That's
right. Natural selection, though, the problem is it can't act upon those near neutral mutations that are unselectable. Those are the ones that build up. Sure, it's going to amplify the best beneficials and get rid of the worst detrimentals. It's the near neutral mutations that accumulate and degenerate our information system. So that'll have to be the problem you'll have to address, Erica.
okay, so when it comes to humans, mutation accumulation, we've seen the mathematics, we've seen a number of mainstream journal publications with Mendel's accountant where you can enter any parameter you want. It is the number one program for simulating natural selection, evolutionary mechanisms. You can even throw in super beneficial mutations, and the math and the simulations, what they show is that most beneficial mutations are too subtle anyways to be selected for by natural selection. And even with a few beneficial mutations, okay, that are, say, truly novel, and because oftentimes they'll invoke what's called super beneficial mutations, those still won't counterbalance the damage of mutation accumulation. So in humans, for example, and recombination, are you familiar with Muller's ratchet?
Not off the top of my head.
Because when it comes to recombination, okay, let's say we're looking at recombination in humans. Well, recombination, David, it primarily works between genes rather than between nucleotides. So what that means is that within any gene sequence, let's say any local gene sequence, okay, there's mostly no recombination. Those blocks of DNA are essentially immune to recombination. So here's where Muller's ratchet, here's where it's a problem. That means that the good mutations, okay, if the good mutations and the bad mutations that are accumulating cannot really be separated, and the bad mutations are deleterious, as we know, and they outnumber the good mutation, that means any stretch of DNA is going to degenerate. So recombination isn't even going to help remove deleterious mutations. I mean, in your own words, how can recombination ever help remove these mutations that are accumulating that need to be filtered out, David?
Hi.
I can't help you here, David. I don't know anything about biology.
Yeah. I'm sorry. I'm just shuffling through notes real quick. I'm sorry.
See, here's the thing. Here's the big problem, though, David, is I want to point out, I want to make it understandable for the audience too. Okay. So here's a simple question, David. Does natural selection act on phenotype or genotype?
I believe from the. I'm not sure I understand this question.
Well, natural selection acts on phenotype, right? It can't see every single nucleotide. And when we pass on our genetics, we're passing on every single nucleotide, of course. So the fact is, every single human being on this planet is mutant. Okay. Right. We've all accumulated mutations. So I like to use the example. Let's take a room full of people. Okay. Now let's kill off the most mutant people. Okay. Get rid of the worst. Because that's what evolutionists typically invoke, right? You know, natural selection is going to act upon the worst. Fine. Everybody's mutant. Get rid of the worst then. But now we still have a room half full of people who still have approximately 100 more mutations than who? Than their parents, and 200 more mutations than their grandparents. Now remember, David, if everybody is multiply mutant, and if every generation is then more mutant than the one before it, all selection can do, it's a fine-tuning mechanism. All it can do is slow down the inevitable degeneration by what? Killing off, like I said, the absolute worst of the bunch. But it doesn't do anything to stop these mutations that are accumulating in the population over time. The ones that natural selection can't really see, that population geneticists refer to as effectively neutral mutations. So that's the point. Things are going down, not up. Yeah, you can get rid of the worst, but it doesn't matter. There's still a mutation accumulation problem that population geneticists recognize. So how do you explain that, David?
Uh-oh.
So I wanted to point one thing out too, John. This is what Gutsick Gibbon, okay, will not actually defend her position on. It's the same thing as with David, you know, and I thank David for doing this, but None of the critics have any good arguments
And I would agree with you because I am also biased towards evolutionary theory.
when it comes to genetic degeneration, the reality of genetic entropy. They're just pretty much denying facts. And that's why when you actually get them in, and I was laughing so hard, John, because Gutsick Gibbon, the queen of dodgeball, dodge, duck, dip, dive, and dodge, she put out a rebuttal video recently on a chapter of one of my books where I focus 90% on genetic entropy. And her argument at the beginning was, well, genetic entropy is not a thing. So whenever he talks about genetic entropy, I'm just going to say it's not a thing and we're going to move on. Yeah, exactly. Because you can't debunk it. And here's the thing. They don't understand. So her main argument, and this was her argument in a debate with me 6 months ago, the natural selection.
Genetic entropy, the answer is selection always selects.
Natural selection, it'll solve the problem. If there's enough damage, then it'll deal with it. But yet they still don't understand the fact that most of these mutations being so subtle to fitness, so subtle to the point where they're invisible to selection. You can't invoke selection on these mutations that are only slightly damaging. And this has been figured out. Mathematically, they've never read the papers. Anyways, John, I'm sorry for that rant. Go ahead.
Oh no, you're fine, man. I went on a few diatribes tonight. Honestly, I feel bad for David, to be honest. Like it's so obvious that he is stunningly brainwashed and is desperate for evolution and his worldview to be true.
Right.
And I mean, to me, when you think about it, like, okay, you have to think about this from like the macro view, not just of him, but in general, right? So theoretically, right, you would think somebody such as David would be doing more research than the average person about like their existence, right? And the requirements for it. But then, as was, laid bare by my little tangent against him towards the end there, of like, he doesn't know what protein domains are. There were so many different components that he didn't know what they were. So, I mean, obviously I hadn't gone and researched them and know about them. And to me, when you contemplate part of the reason people like Dr. Dan crack me up when he talks about like, you just don't know what you're talking about. And, you couldn't pass. I dare you to take my evolutionary biology 101 class. It's like, it's why I just kind of crack up and laugh. It's like, you know what, bro? Congratulations on being able to convince people like David that your bullshit, excuse my French, is true. But it's easy to convince people who don't know what you're actually what you're trying to convince them is true, and like the underlying requirements for it to be true. Which, in the context of what we're talking about right now, of yeah, man. So you can't account for transcription factors, but you admit that they're required. And that life can't exist without them, but you don't know how they came to be, and you can't explain it, and it's not plausible for it to be explained. And in your own lab, without all sorts of tools, you can't recreate them. In their own lab, in a modern lab, you can't recreate them. And you're telling me that it just evolved, and that you just need to accept.
John, changes in allele frequencies, okay? Changes in allele frequencies over time in populations over generations. I mean, what are you? Just denying science? What are you, pseudoscience? Of course pond scum evolved into people because changes in allele frequencies.
I think the thing that really got me more than anything, and I really, like I said, I'm not trying to bash on David.
No, it's not David. Everybody says this.
It's all James. I'm using as an example, but like, the whole thing about like, was it evolution or was it devolution? Like, was there something that existed before and now you don't have it? Like, you had this capacity, now you don't. What is that?
Right.
That's evolution. Like, what? No, you literally lost something. So you claiming that you're just going to regain it? I occasionally go into like the Open MIT platform. Mm-hmm. And we'll watch different things. And just for giggles, I was rewatching the one of their lectures on genetic transcription, I think it was. But the professor made the point of and don't forget things like drug-resistant bugs. It's actually errors in reduction in information that changed the shape, which enabled them to avoid the antibody. But they were in the lecture literally making the point, this is not an increase in information; it's literally a decrease.
Could you imagine?
And it's that's what blows my. Sorry, to finish my point. That's what blows my mind about these talking points that we.
Right.
It's I'm literally watching a lecture from MIT about the subject, and they're literally stating reduction information. It's a misfold or et cetera, et cetera. And then we come on YouTube and we listen to atheist evolutionary activists running around claiming the literal what is being taught at MIT somehow proves their point, when it's literally the direct antithesis is what's being taught at MIT. What the? I don't know where do I have to go? Are you gonna this is what gets me about Cardinal. I'm dude, I literally challenge you to have the C.O. Jones to go to one of your peers at MIT, at Yale, at Harvard that are on public lecture are stating the exact opposite of what you claim is true. I literally dare you, because
but then he'll have egg on his face like this. Yeah, no, it's
sorry.
It's
sorry for my long-winded diatribe there.
No, that's good.
I yield.
No, I've done the same thing. All good points. See, could you imagine being an evolutionist who believes that life came from non-life, and then that first life evolved into a multi-celled organism, into a fish, amphibian, reptile, mammal, bird, monkey, man, and you ask them, what's the best evidence you got? And it's this Dan argument about the SIV. And we did a rebuttal to Dan a while back. There's been no response. And Ramat pointed out that the SIV in chimps that David was pointing to transferred over to humans and became HIV. And apparently the SIV doesn't affect the chimps at all, but in humans it does, and it's bad. Can you imagine being an evolutionist? And that is the best example you have for why pond scum ultimately evolved into people. Bacteria-like organisms evolved into whales, people. I mean, and John, I'll typically just say, fine, have a couple of those. Let's really just say that they're truly beneficial and not reductive. Still hasn't answered the problem of mutation accumulation and genetic degeneration. I don't know. You know what I mean? What are your thoughts? Could you imagine?
Is 6.5 million years enough time to account for 1,400 new genes with 35 million nucleotide differences? Right. Well, there was 350,000 generations. Right.
Yeah. Right.
Okay. So literally, do you understand the number of mutations? Not just mutations that happened. We're talking about beneficial mutations that have to be conserved. They have to become fixated.
Right.
You have to have all of these fixated mutations that
John
result in new function. What?
Remember, John, and we're giving them the changing allele frequency. We're giving them the conservative number. We're giving them 35 million. When all's said and done, you're looking at roughly 400 million DNA differences. That's it. Evolution's done. I like what Godzilla Freak said here. Lactose indigestion, like destroying a door so you don't need to open it. Beneficial mutation. And this is why. So Erica, completely flop, fail, dodge, duck, dip, dive, dodge all over the place. Evolutionary fitness, right? She thinks we're changing the definition of evolutionary fitness. When in fact, no, they're the ones that don't understand the difference between reproductive fitness and absolute fitness, okay? If you have... Let's say, we've used the examples of the blind cave fish or the wingless beetles, okay? A lot of these mutations result in reduction, but not reduction to the point where they can't still have babies. But overall, it's still a downhill process. And they don't want to acknowledge
honestly, at this point in modern society, walking around, have you seen the people with children?
Yeah, exactly.
Okay? If you're going to claim that just because you can reproduce... Have you seen the people walking around with kids?
Yeah.
I'm just saying.
There's a lot of defects, birth anomalies, birth defects that are bad, but not bad enough to prevent somebody from having a bunch of kids, and those kids are still going to have the mutation. That's why when I pointed to David, when I pointed, and he's not the only guy I pointed this out to, the analogy with the room full of people, everybody's mutant. Like, for example, everybody in the chat here, all 40 people, you and I, we're all mutant. We've all got mutations, and selection acts on the phenotype. Selection acts on the entire organism.
Listen,
Okay.
y'all. There is no way that male pattern baldness is a positive mutation. Okay. All right. My head shaved because I got that one. So I don't know what to tell you. That is not a positive beneficial mutation. I can't go where it's cold now without a hat. Okay. This is a serious problem.
Well, see, here's the thing. Like, here's this comment. I thought only reproductive fitness mattered to natural selection. So natural selection, better understood as differential reproduction. Who's having the most babies? You got to pass on their genes. But here's the thing. There's a lot of mutations that are bad, but they're only slightly bad, slightly harmful. So you can still have kids and yet pass on these deleterious mutations. So reproductive fitness, sure. But when it comes to total functionality, absolute fitness, no, it's still degrading, functionally compromising. That's what we see. They have no answer. And what are your thoughts, John? I mean, reproductive fitness is going to save the day, apparently.
Here's the thing that gets me. And this goes back to the core, either just refusal to or the inability to comprehend what we're talking about on a data level, right? Like, you have your computer. Is over time, can you still boot your computer up? Yes or no? Okay, yes, you can. Awesome. Does that mean that it's still as fast as it was when you first bought this stupid thing? Probably not. Is over time, does data get corrupted? Yes, it does. If you put it in, can you still turn the stupid thing on? Can you still use different functions? Yes, you can. Is it still as good as when it was brand new? Obviously, the answer is no. So what the hell do you think is happening with life? Like, this is not exactly a complicated thing to comprehend.
No, it's not. I don't understand why. It's pretty sad when the best they got, your Ericas and your Dans, and I'm not even saying they're the best, but it's just so funny that they think just pointing out the fact that reproductive fitness, is what matters in evolution. Like, that's going to solve this problem. I like you said, I like to point to the car. Okay. A big enough problem where the car is not going to work anymore. It's just done, is if randomly the engine jumped into the back seat. Yeah. That's a pretty major problem. That's detrimental. That car ain't going to be driving anymore. Okay. Those are the problems that can be noticed. But here's the thing. All those little rust spots that build up over time, the ones that are essentially invisible to the car, okay? You can still take your car in for frequent oil changes, servicing, change the tires, do whatever, but the car is still eventually going to rust out. It was the best when it came off the line. And it's the same thing with mutations in biological organisms. Yeah, selection will get rid of the worst, but we're still degrading. Go ahead, John.
And here's what really pisses me off about the stupidity of these arguments. Okay, so as a dude, as we get older, the sperm in our balls gets less, or it gets corrupted. Like, this is a fact. This is a fact. Okay. So if you have kids when you're older, the mutations they're going to have are going to be higher than if you had the kid when you were younger. Like, this is a well-established fact, right? So if we can prove beyond all doubt that something as simple as having kids when you are older is going to mean they're going to have more mutations than when you had them when you were younger. And they're going to be negative. Like, this is a proven beyond all doubt thing. Like, you don't, as a man, you want to try and not have your kids after 36 because there are all sorts of diseases that have been like identified that fathers over 36 probability of the kid having X, Y, and Z is like skyrockets. Right.
Right.
And there's some things with women, but it's much less because the eggs, have much different corruption level. But with guys, like, our sperm starts to corrupt big time, right? Every year that goes by, And then at 36, and you're just going on downhill from there. But I mean, okay, we know this is true. Why would you think that if that is true, that overall degradation of the genome over time would not also be true? Even though that it might have been slower if you had the kids when you were younger. That still means they're going to have mutations that you didn't have, and their probability of having diseases is higher than yours. Like, this is not exactly rocket science. I don't understand how this is so complicated for people.
Here's the thing. The reality of genetic degeneration, like you said, John, it's not that hard to understand. The evolutionists have to pretend to not understand it because it destroys their worldview.
But hey, new functions come. Oh my!
John,
I don't want to deal with
changes in allele frequencies. Oh, I want to point out something too. This whole Neanderthal question. In my debate with Walker, I answered it. Actually, I'll point out this comment from Graham. We have a near catastrophic number of near neutral mutations. The human race could not survive more than a few hundred more years, few hundred generations. We could not be more than 10,000 years old as a race species. That's true. That's the point. Genetic entropy puts shelf lives on genomes.
If we did, okay, it's recognized that if we didn't have modern medicine, we probably wouldn't make it to 40. I mean, this is, or not far past 40. Like, this is a recognized premise. And it was, well, modern medicine and modern nutrition, right? If we didn't have all of the ability to all this food, right? Like, and you think about this, why is there such categorically different ages of death in humans, right? You've got certain demographics that are dying very young and others that are living a long time, right? How can there be this stark difference? Most of it's not just susceptibility to disease. It's either access to different drugs that can stave it off, right? And or a combination of much better nutrition, which enables you to slow down the outcome. But if you remove those things from the equation, we'd be dying young. Very young. So, I mean, this whole premise that we're somehow evolving to get better, it's like, no, we've got better technology. We would be dying. We would be dying younger, you idiots. Like, this is...
I pointed that out to Jim Majors, good old Jim Majors, your best friend, John, in our debate, where he said, we're living longer than we ever have. And I pointed out the fact that the average lifespan, has maybe gone up because of modern technology. We're helping each other out, medical intervention, but the maximum lifespan has not gone up. It's actually decreased. So we're not getting better.
I mean, think about this just as an example. Like, more women are getting breast cancer. If we did not have massive increases in both the identification of and the treatment of, and heck, just the ability to do a mastectomy, right?
Right.
There would be a plethora of women that would be dying young. The age of prostate cancer is getting younger, right? Not older, younger. So again, do we have great ability to treat prostate cancer now? Yep. If we didn't, would you die? The answer is yes, right? Same thing with melanoma and like all sorts of different cancers, right? People are getting them younger and younger and younger. So again, if you don't have the treatment, are you going to die younger?
Right.
If you can't stop metastasis, yes, that is the answer, right? I mean, I know you have a little bit of a background in healthcare. Would you agree with that, what I just said?
Yeah, absolutely.
And blessings on you.